It is possible to solve a system of linear equations using a TI83 or 84 calculator by putting it in as a matrix. So that's what we're going to do. We're going to go through a couple examples of putting it in the calculator and getting a solution using the calculator's matrix functions. So first off is we have this system of equations here, and we're going to plug it into our calculator. So first thing I'm going to do is bring up my calculator. And now I'm going to put the matrix into the calculator, and I've already done that ahead of time, but I'm going to show you how to do it again anyway. So we're going to go to second and matrix right here, the x -1. Press second and then this button here to bring up the matrix. To input the matrix in, you're going to scroll over to edit, and you're going to select the letter you want it to be put in. So first one is going to be for A. And this is a 3x4 matrix, 3 equations, and 1, 2, 3, 4 columns. So 3 by 4. So that's what you're going to have here, 3 by 4. And then what you put into the matrix itself is the coefficients of each part. So 1, 1, 1, 2, 1, 1, 1, 2, then 2, -3, 2, 4, and then 4, 1, -3, +1. Once it's all put in, and it never hurts to double check, but once it's all put in, we're going to go to second and mode to get out of it. Then we're going to go to second and matrix, and we're going to go over to math, and you're going to want to select reduced row echelon form. It's going to be abbreviated as RREF. Don't pick REF, you want RREF. So we're going to choose this option. And then we're going to go back into second matrix one more time and select the matrix we want to reduce. So we want A. So enter here, close parentheses, and enter again. And here we have our matrix with the diagonal of all ones, which is what we want, and the answer being 1, 0, 1. So our reduced, that's an F, our reduced row echelon form is 1, 0, 0, 1. 0, 1, 0, 0, 0, 0, 1, 1. So there is our reduced row echelon form. So our answers here are x equals 1, y equals 0, and z equals 1. So the solution is 1, 0, 1. And that's how you do it. Now let's do it again for this matrix. So again, I'm going to bring up the calculator and show it again how to put it in. So it's just going to be second and x -1 for matrix. Go over to edit, and this time I'm going to select B. So hit enter, and again it's a 3 by 4. Even though y is missing here, we just let that coefficient be a 0. So it's still 3 rows by 4 columns. So 3 by 4. So again, 1, 2, -1, -2 for the first row. 1, 0, since there is no y, we put a 0 in as a coefficient. 1, 0, and then 2, -1, -1, -3. And once you've double checked to make sure everything's right, we're going to go second in mode to get out. Second matrix to go get the reduced row echelon form. So we go down to reduced row echelon form. And then we want to select the matrix we want to put into this form. So second matrix again. We're going to choose B, close the parentheses, and then there is our option, our diagonal of 1s, and the answer being -1, 0, 1. So the reduced row echelon form, 1, 0, 0, -1, then 0, 1, 0, 0, then 0, 0, 1, and 1. So there it is written out. So the solution here is x equals -1, y equals 0, and z equals 1. So the solution, -1, 0, and 1. So we've had a bunch of 1s and 0s and -1s and whatnot. Let's do something a little bit more colorful. Let's do this system here. Much bigger numbers, much more going on. So we're going to do it again. Second and matrix. Over to edit, and we're going to choose option C. Again, this is a 3 by 4. And so 2, -3, -1, 13. -1, 2, -5, 6. Then 5, -1, -1, and 49. Always double check, and once you're sure it's good, second mode to get out, second matrix, over to math, go to RREF, select, and then back to second matrix one more time, and we're going to choose the matrix C. Close, and then hit enter, and here is our matrix, a diagonal of 1s, 10, 3, and -2. So the reduced, again, not an F, again, the reduced row echelon form is 1, 0, 0, 10, 0, 1, 0, 3, and 0, 0, 1, -2. So there is our matrix in reduced row echelon form. So our solution here is x equals 10, y equals 3, and z equals -2. So 10, 3, and -2 is our solution to this system of linear equations.